Hello, my name is Paul Bevan from Siemens Digital Industry Software, and in this demonstration I'm going to show you the power of synchronous modeling within NX. Currently in the graphics window you can see a radiator fan assembly for a car. Now, due to a new engine variant we need some more cooling, so I'm going to perform a feasibility study to see if I can add an extra fan to provide that cooling. To start, I'm going to remove a couple of the components so that I'm just left with a housing for the radiator fan. And we're going to make that our working part. So everything I do now is going to happen inside of the radiator housing. I'm going to construct some reference geometry that I'm going to use for the feasibility study. The next stage in the process is to remove the current single fan shroud. And to do this I'm going to use Synchronous technology delete face. Here I just window round the geometry that I want to remove and then complete the command. This removes all of the geometry and also heals the apertures, so I'm just left with my reference geometry. Now I'm going to move that reference geometry, so I'm going to construct some sketch geometry and now move the whole profile from one point to another. So here I'm moving it from its original position to a brand new position. Moving to a two-fan configuration means I can probably utilize smaller fans. So I'm going to adjust the size of the footprint. I'm going to resize the reference geometry that I created. Here I'm just modifying the diameter. Now I'm going to add an offset, and this is going to be the aperture for the fan, and I'm going to control the diameter of the inner and outer profiles using a dimension. Just going to swap it to a diameter dimension. So that's the first one done, and then the second one I'll add in as well. Again, we'll create this as a diameter. You'll also notice I'm going to create an expression associated with the dimension so that I can reuse that later on in the design study. Now to add the second fan, and it's really easy to do. I just select my original profile and then copy drag the geometry to an open area before finally tying down the position using tools similar that I did for the original profile. So again, I'm going to use point to point and then finally rotate the profile through 180 degrees. And there we have our second fan positioned, and as you can see we've got clearance between the two. Now that we've confirmed we can include a second fan using our 2D profiles, we can now start to add detail back into the design. You can see in the Part Navigator the delete face feature we used earlier to remove the original detail. Now it's time to bring that back, so we can simply delete that feature. And there we have the original fan design. All of the synchronous modeling commands in NX create a feature. And it doesn't matter if you have a non-native NX part, as we have here with just a body in it, or a fully featured NX design. The synchronous tools work exactly the same. If you remember in the 2D design study, we changed the diameter of the footprint of the fan shroud. So we now need to replicate this in our original data. So I'm going to use the radial dimension synchronous command. I select the command, I pick the face that I want to change, and I can also use the power of Face Finder to find other faces I'll need, such as offsets or equal radius faces. Notice it's automatically finding all of that geometry for me. Now all I need to do is to change the diameter, and to do this I'm going to simply reference the expression I created earlier in my 2D profile. I select the profile, the dimension, the expression is referenced, and you can see the preview, and then that particular diameter is updated. We'll do the same for the outer diameter. Again, look at all of the extra geometry I'll need, and again reference the expression from our earlier 2D profile. Again, you'll notice the geometry update. Very easy and very simple to do with synchronous technology. Now that we've updated the size of our fan shroud, we need to update the size of the fan assembly. So I'm temporarily going to remove the 2D profiles and bring back the fan assembly. Now the fan assembly itself is a reusable component, and when we come to edit it, we're presented with a user interface that's been pre-configured. Here I can change the size of the fan, the number of blades, the working RPM of the fan, and various other parameters. Notice as I make changes, the fan assembly dynamically updates, and when I'm happy, I can accept the new design. The next stage is to add the detail for the second fan shroud, and again we'll use synchronous commands to do this. The first one we'll use is copy face. Here we'll select the geometry from our modified shroud, and we'll reposition it using a reference point and then a go-to point. Once we've done that, we can now rotate it through the 180 degrees, if you remember, from our 2D profile, and we'll OK that. And that's a copy of that original geometry, and I'm temporarily going to hide it. The next design change is where you'll see the true power of synchronous modeling inside of NX, as we change the position of the updated fan shroud detail. I'm going to bring back the fan assembly components, and now I'm going to utilize synchronous move face. We use a similar technique to select the geometry. I'm just going to window around our updated detail and then use a point-to-point transform. So I select the center point of my current shroud position and then move it to a new position. I get a preview of the new position, and if I'm happy with it, I can complete the command. Notice now that all of the faces from our original fan position have adapted to the new fan position. Just imagine how long that would take you without the power of synchronous modeling. You'll also notice that as the other fan components were linked to the shroud position, that they've automatically been repositioned too. Now let's add the second fan. First I'm going to hide the fan assembly components and then bring back that copy geometry. We can take a look at the other side of the component, and we see we're going to need to remove some material for this new fan shroud. So I'm going to use the extrude command and select an edge off the copied geometry and subtract it from our component. There we have the aperture completed. Now the copied geometry is a set of faces. It's not a solid body. So I'm going to use synchronous paste face. This allows me to select the original geometry and then the faces I want to paste in, and it's as simple as that to include them into the overall design. Finally, I'm going to create the aperture for this component here, again using just standard modeling within NX. I can extrude a profile and subtract it. We have one more slight modification to make, and that's to combine two faces. We're going to use replace face, another synchronous command to do this. We select our original face and the face that we want to replace, and notice now that the two are brought together. Again, another powerful command in synchronous modelling. And that's the design study complete. You've seen the power of synchronous modelling inside of NX make extremely complex changes look easy. In a matter of minutes, I was able to reconfigure the design to include a secondary fan to assist with cooling. And here's the completed assembly with the second fan added. I'd like to thank you for your time and attention.